Greetings to everyone. Myself, Dr. M. Harihanan, working as Associate Professor in Department of Civil Engineering in Mari Lakshman Reddy Institute of Technology and Management. It is an autonomous institution which is located at Dundigal, Hyderabad. I am handling the subject of surveying and geomatics to the second year civil engineering students. Today we are going to discuss about what is contour and uses of contour map, and what are all the characteristics which the contour have, and what are all the methods available to find the contour map or to place the contour map. That we are going to discuss by today's class. Let us move on to the definition. The contour definition is: it is an imaginary line which connecting the same elevation of points. Okay. For example, here they have denoted as 1800. So in this figure they have this line in the form of darkened brown. So this line should connect 1800 meters, okay, wherever the point it have the elevation or reduced level. Okay, so this line is called contour line, have the elevation or reduced level of 1800 meters. Similarly, here this is 1950. Okay, here it is 1800. Okay, and here it is 1200, 1050. So likewise, so the line joining equal elevation of points is called contour. Next, contour interval. Okay, the vertical elevation between the points, that is between the consecutive points, is called contour interval. Okay, here in this diagram 1800, here it is 1950. In between that there are 5 lines: 1, 2, 3, 4 and 5, fifth one. Okay, so the difference 1950 minus 1800 divided by 5 gives the distance of 30 meter each. So from the 30 meter for each line, okay, now here it is 1830. This one is second line 1860. The third one is 1890, and the fourth one is 1920. Okay, so this 30 meter distance or 30 meter interval with respect to vertical height is called contour interval. Next, horizontal equivalent. This is nothing but the horizontal distance between two consecutive contour lines is called horizontal equivalent. Okay, so that one with respect to the field we are going to find it. Okay, now based on our previous problem, whatever we have discussed in the height of collimation method or rise and fall method, by using that I will explain the thing right now. So this problem we have discussed already. Okay. So from this problem we are going to find it. So this is our RL. Okay. By using this RL only we are going to find it. Okay. So we already know that this is a continuous sloping ground. So this is our first point, that is benchmark point. It have the height of 80.750. This is point number 1. So likewise we are having some 12 points. Okay. And each point having the sloping ground of 30 meter. Okay, this 30 meter interval is called our horizontal equivalent. Okay, .975. So likewise I am going to fix or mark all these points in the diagram here. So these are all the levels with respect to this problem. Okay, that I have denoted in the figure. Okay, now so each distance, each point have the consecutive distance of 30 meter interval. So this 30 meter is called our horizontal equivalent. Now the vertical, that is contour interval. Okay, so here it is 80.75, here it is 79.975. This difference, okay, between this difference or distance between these 2 points, 2 consecutive points, is called our contour interval. 80.750 minus 79.975 is called 0.775 meter. That is called our contour interval. Okay, so likewise we have to get it, or we have to extract. For example, we have to go for the some round up value. For example, 80.750 is that, 79.975 is that. In between that we are having 80. Okay, 80.0. okay, so that we have to find out. That is called interpolation of contouring. Okay, so in between that point we are having this 80 meter distance. Similarly 79.57, 79.100, 78.575, in between that we are having some 79.00 meter. So finding of this position for the round up value is called the interpolation of contour. Okay, similarly 77 is somewhere here. .78 is also available. Okay, next 76 is also available. Next 75 is also there. So likewise our contour. So finding of this position is called interpolation of contouring, and here if I am going to this field along this line, I can get only 80-meter line. Okay. Similarly, if I am going like this, I can get 79 meter. If I am going like this, 78 meter. So the line joining the equal elevation, okay, now is called contour. So the vertical difference, that is 1 meter, 78, 79. That difference is 1 meter. So that vertical distance between two consecutive contours is called contour interval, and the distance between the horizontal distance between the two consecutive contour is called horizontal equivalent. Okay, so these are all the things which are related to our contour. So these are all the definitions. Okay. Next, uses of contour maps. Okay. So there are lot of uses which we are having because of contour. Okay, now. So whenever we are dealing with the quantity of work, okay, now, like earthwork excavation, earth filling, or finding the route map. Okay, now finding the route map in the sense for distributing the water. Okay, now from dam to the consumers. Okay, now so that path should be very clear. Okay, now that means the reduction in level should be smooth manner. Okay, now similar way our highway and railway for the particular region. Okay, now between the stations points. Okay, now that is also in the smooth manner. Even though at the hilly area, the importance of this contour map is very essential, since we have to reach our hill in the form of very smooth gradient. Okay, now all of the sudden we cannot climb up. Okay, now similarly all of the sudden we cannot drop down. Okay, now so we have to make some clear gradual gradient, then only with the vehicle can climb up and reach the hills. Okay, now so these are all the main things are related to our contour maps. Okay, so now first, drawing of sections, which means we have to prepare a contour map. The section along any given direction can be drawn to know the general shape of the ground, or to use it for earthwork calculations for the given communication line in the direction of the section. Okay, so with the help of contour we have to make a clear plan. Okay, now by using the plan we have to get the data like earthwork excavation or earth filling for the smooth reaches. Okay, second one, determination of intervisibility between two stations. Okay, here the distance between the triangulation stations, okay, are placed generally several kilometers apart. Okay, so before selecting their position, it is the necessary to determine its intervisibility between them. Okay, now so then only our work progress will be easy to us. Okay, next, tracing of contour gradients and location of route. So this one I already said in the beginning, that is a contour plan is very much useful in locating the route of a highway, railway and canal. Okay, or else communication line like power line or telephone line, like that. Okay, so these are all the, even the winch. Okay, now that is also comes under communication line. So for that we have to get a clear path with the smooth gradient. Okay. Then fourth one, measurement of drainage areas. Here the contour map is very essential, so that how much quantity of water we are getting in the catchment, okay, or from the river or stream, whatever it may be, that we are going to calculate. Based on that thing only, we have to arrive the distribution system, okay, which means how much consumers are going to get benefited because of that water available quantity, okay, now that we are going to arrive. In the same way, fifth point, that is calculation of reservoir capacity, okay, now that is also is an essential part of our contour map. Since from the help of contour map only, we are going to find out the catchment area, which means how much water we can stock, that we can find out, okay, now based on that quantity we can arrive the beneficiary numbers, okay. So these are all the things are related to our contour map, uses of contour map. Then sixth one, intersection of surfaces and measurement of earthwork. Here this is purely related to our highway and railway and canal work, okay. Now during the work we are going to take the cross sections, okay. So by using those measurements we can arrive the quantity of work, okay, that we are going to get it. So these are all the some uses are related to our contour map. Now we can discuss about the characteristics of contours, okay. So the contour have some characters like us, okay. So some individuality, okay. Now what are those individuality and how it is get benefited for us, okay. Now in the contour map we can get these data like their characteristics, okay. Now so in this line we can have, okay, now the contour line cannot merge, okay, now with the, that is each and every line is separated like individually, okay. Now so which means this is, here we can discuss, so 1800 meters, okay. Now then 1830 meters height, this is 1860 meter height, these lines, okay. Now so it won't intersect each other, okay. Now so these are some characteristics of contours, okay. Now that we are going to discuss. So contour lines must close, not necessarily in the limits of the plan, okay. So this is our site plan, okay. So this is the sloping ground, that sloping is in the direction of arrow, okay. Now so if I am going to take it, this is my base point, that is 100 meter, okay. And if I am going to 101 meter, the line should be like this. This is my 101 meter, okay. So the next line is 102. So likewise it can get increased, okay. Now but with respect to my land only I have taken the reading, okay. So the line of 100 meter or 101 meter or 102 meter cannot be closed within the plan itself, okay. Now so this line may be prolonged here also, that is our neighborhood site, okay. So we never bother about others property, we should bother about only our property. So this is related to our first point, okay. Second one, the horizontal distance between any two contour lines indicates the amount of slope and varies inversely on the amount of slope. So here, so this is my horizontal line. Okay, I already said this is 80-meter line, this is 79, this is 78. Okay, the horizontal distance between these two are the consecutive contour lines, indicates the or denotes the slope of the ground. Okay, so from this, if it is equally spaced, then it is a fairly leveled ground. Okay, if it is get closed, okay, like this, okay, now then it should be called as steep ground. Okay, now since the height, this is 79 meters, this is 78 meters, sorry, 77 meters, 78 meters, 79 meters, 80 meters. Okay, now suddenly the heights get increased, so it indicates steepest ground. Okay, now so likewise some characters. And widely spaced contour indicates flat surface, so we all know that. So second one, closely spaced contour indicates steep slope ground. Okay, then equally spaced contour indicates uniform slope, so which means from here, 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 like this. Okay, now then my level of ground is uniformly spaced, so automatically 100, 101, 102, 103. So my ground is having the uniform slope. Okay, then irregular contours indicate uneven surface. Okay, in this diagram, contour diagram, so this is irregular shape of our contour. Okay, so this indicates uneven surface of the ground. Since here you may think that this is 1200. Okay, now here they have somehow closely spaced. Okay, now after that it is enlarging. Okay, so these things indicates our ground have uneven surface. Okay, so here with respect to this figure, okay, so here the contours are closely spaced so that it indicates steep terrain. Okay, and here, okay, now it have some equal spacing here, so that which denotes the uniform slope of our terrain. Okay, now this is with respect to our second point. Third one, approximately concentric closed contours with decreasing values inside indicates a pond. Okay, which means consider here, so here they have mentioned as 86 meters. Okay, so after that, if I am going to take the reduced levels here around the pond, then the reading gets increased. Instead of 86, it is moved to 90. So 90 I am getting here. Okay, and next, if I am going to increase the height once again, okay, now I am taking the reduced level, so it becomes 95. Okay, now once again, if I am going to take here, it is 100. So the reading in the inside when compared with the outer side reading, okay, now it's getting reduced. This kind of contour denotes it's a pond or lake. Similarly, if it is a hill, okay, then I am taking the reading here, so this is 100 meter. Okay, so I am getting the line somewhere here, so this is my 100-meter line. So I am taking the RL around the hill. Okay, now So this is my 100-meter line. Next I am moving towards the height is increasing, so that it is called 101. Okay now. So here. So my lines are somewhere here. This is called 101 meter. Then here. This is called 102 meter. Okay. And this is my peak point. So this is 103. 103. Okay. Here the lowest value is at outside, the highest value is at inside. If it is like this, then the contour represents hill area. Okay. Here the lowest value is at inside and the highest value is at outside. This denotes the pond or lake. So this is the difference between the contours for pond and contours for hill. So it is available here. Next, the contour with U shape with convexity towards lower end indicates ridge line. Okay. The contour with V shape with convexity towards higher ground indicates valley. So the valley line and ridge line are denoted like this. Okay. So where we can get ridge line and valley line? Okay, only in the hilly region we can get this type of ridge and valley. Okay, so in the ridge, the inside the values are high and it's getting towards outside, it's get lowered. Okay now, but in the valley line and also in the ridge line, the shape of our contour line is U shaped. Okay now, but in the case of valley line, okay now, that is steep slope suddenly gets dropped down from the hill to our toe of the mountain or foot mountain. Okay now, then it should be like this. That means the sudden V shape of the contour profile we can have for each and every line, and here it is the highest contour point is at outside and the lowest point of the contour line is at inside. So this is the difference between the valley line and the ridge line. Next, contour lines generally do not meet or intersect each other. Okay, we already seen this, but it can meet or it can unite. Okay, now only in the case of vertical cliff. So I said in the hill means in the hill area means the reduced level of contours are like this. Okay now, but in the case of vertical cliff, okay now, it can unite like this. Okay, so this is my 100 meter. Okay, and here it is 101. Okay, so for the 100, if I am going to draw the contour, then it becomes like this. So this is the 100-meter line. Okay, now then for 101 also, if it becomes somewhere here. Okay, but in the case here it is same thing. So this is also 101. So the point are joining here. Similarly 102. So this is 102 meters. So likewise here the point of each and every height is at same level or same position. Okay, so this denotes the contour or the profile of hill having vertical cliff. Okay, now then only our contour can be unite or is at the intersect each other. Okay, in the same portion. Next, overhanging cliff. Okay, the contours of different elevations cannot cross each other. This is one property we have discussed at very first. Okay, now but it can cross each other only in the case of overhanging cliff. It is like this. Okay, since here it is 100 meter, here the height is increasing to 150 meter, here the height is increasing to 200 meter. Okay, but once again if I am going to here, the height is increased to 250 meter. Okay, now when I am drawing this, these two lines of contours have intersect each other. Okay, so this should be happened only in the case of with overhanging cliff. Next characteristics. The steepest slope of terrain at any point on a contour is represented along the normal of the contour at that point. So this point we have discussed here itself. Okay, this is with respect to our steep terrain. Based on the terrain, our normal profile will be like this. Okay, then next, contour do not pass through permanent structures such as buildings. So here, since we while taking the reading, here the building is the interruption. Okay, so we cannot take the reading inside the building. So that's why the contour do not pass through the permanent structures. Okay, since we cannot take the reading inside the building, that's why it won't cross the building or it won't pass the building. Okay, even it's not a building at any permanent structures. And last point, the contour line must close itself but need not be necessarily within the limits of the map. This one we have already discussed, that is it won't close within the plan itself. Okay, no, it may be somewhere, okay, along the neighborhood property. Okay, no, it might be close or it may not be close. That is depend upon our property line. Okay, so these are all the some characteristics or individuality of the contour lines. Next, we should move on to the topic of methods of contouring. So there are two methods of contouring. Okay, now so one is direct method and another one is indirect method. So first, what is locating the contour? Okay, now which means in the we are going to take the reduced level of the field. Okay, now what of the field which may given or we have got it. Okay, now for that we have to take the reduced level. Okay, so how the way and what are all the methodology we are going to use to take that reduced levels in the field. Okay, now those things are called as methods of locating contour. Okay, now there are two methods, one is direct method, another one is indirect method. Under the direct method, we are having two things. One is vertical control, another one is horizontal control, which means the surveyor and the helper together they are going to do. Okay, now first in the direct method I am going to place the instrument at one location. Okay, now for example, if I am going to locate the instrument here, this is my field. Okay, so in my field, with respect to benchmark, what is the height I am going to get? Okay, now for example, 100 meter if I am going to get, where and all I can get the 100 meter. Okay, now that I have to decide as a surveyor. Okay, now so this is my 100 meter line means, so these points I have to select by trial and error method. Okay, now first I am going to place. If I am getting the 100 meter means I can choose that place. If I am not getting 100 meter, then I have to shift my leveling stuff into some other position. So likewise, I am going to fix my reduced level. Based on that, I am going to work on the field. Okay, so this is the difficult and it is a waste of time. Okay, while doing the project or while calculating the reduced level. So that's why we are not using this direct method in the field. Okay, now but indirect method we are going to use at every time. Okay, now so those indirect methods are, one is by square or else radial method. Okay, second one is by cross sections, third one is by tachyometric method. So in the radial method, I have to place my instrument at the center of the field. Okay, after that what I am going to do now, randomly, okay, now my instrument either in the dumpy level, okay, now I have the horizontal angles 0 to 360 degree, so I have to fix. So this is 0 degree line. Okay, so this is some 60 degree line, this is my 120 degree line. Okay, likewise I have to fix it. Okay, so in the 0 degree line, okay, now I have to keep the tape from 0 meter to till the end of the site. Okay, now so that some common interval like 5 meter or 10 meter or 20 meter, okay, now based on my nature of the field, I have to take the leveling stuff reading along the line of my 0 degree. Okay, 60 degree, 120 degree, likewise. So I can get my reduced level randomly over the entire site. Okay, so by the method of interpolation, I can get the, or I can fix the contours in the site. Okay, now so that interpolation is separate part. Before that, this is the methodology I am going to use to get the RL of the field. Okay, so next, by square, which means here the land has been divided into number of, with corresponding to the angles I am taking the readings. Okay, now instead of that, my land has been divided into number of pieces of squares. Okay, now to the corresponding intervals. Okay, so the field has been taken into 10 meter or 20 meter or 5 meter interval. Okay, now likewise some 10 meter or 5 meter. Okay, now so similar way in the both direction, longer span as well as shorter span. So wherever I am having the points, junctions, okay, now that place I am going to keep the leveling stuff, and my instrument should be at somewhere in the elevated position so that all the points should cover. Okay, now here I am reducing my number of changes points. Okay, so wherever I am having the junctions now, at the junction I am going to keep the leveling stuff so that I can get the RL of the points in the field. Okay, After getting these points, with the help of interpolation, I am going to make the contour map. So this is by square method. Next one is by cross sections. Okay, so here they have clearly denoted about the squares. So this is my site. So each and every corner I am going to take the readings. By using that readings, I can calculate the RL of those points. Okay. So this is the 101 meter line. Okay, which crosses. This is our contour of 101 meter. Okay. So each and every corners like this I can get it. This is by square method. That is, entire area of the field has been divided into number of squares. Okay, number of pieces of squares. Next, by cross section. This method is most suitable for the survey like a road, railway, canal or water supply scheme. Okay, now whatever it may be, like this, so that our when comparing with the breadth, the length should be very, very large. Okay, now that time we are going to use by cross section method. Okay, now here the number of change points is increasing. Okay. Next, by tachyometric method. Here the tachyometric method means with the help of elevation. Okay, that is the difference between the difference between the diaphragm reading, whatever we are going to look at in the leveling stuff. Okay, now based on that level difference in the leveling stuff and the angle whatever we are having with respect to the middle hair from the instrument. Okay, now by using that we are going to calculate the horizontal distance. This is called tachyometric method. Okay, now so where we can use this tachyometric method means if the grounds are highly undulated. Okay, at the time we can go with this tachyometric method, since we are in the need of horizontal distance between the instrument to leveling stuff point. Okay, now but because of this undulation we didn't get, since if we are going to use the tape, we may get the chance of that undulated ground length. Okay, so we are in need of only the horizontal distance between the instrument to leveling stuff. That's why we are going to use this tachyometric method. So these are all the methodology which we are going to use for finding the contour. Next, interpolation of contours. So interpolation is the process of spacing the contours proportionality between the plotted ground points established by indirect methods. So these methods of interpolations are based on the assumptions that the slope of the ground between the 2 points is uniform. Okay, here they have done the square method. Okay, now with the help of square method they have calculated the reduced level. Like here it is 100.8, here it is 100.5, here it is 100.3, here it is 99.8. Okay, here it is 99.3, 98.6 and 98.5. In between that the round up value 100 is available. Okay, and the 99 is available. So how to find out this point? Okay, now that is called interpolation. Okay, there are two methods of interpolations are available, that is by estimation, second one is by arithmetic calculation, and third one is by graphical method. Here whatever it shows now, that is called graphical. Okay, so by assumption we can take. Okay, but by means of estimation and by arithmetic calculation, that will give somehow accuracy in the result. of position of contour. For example, 100.8 is there, here 100.1 is there. So in between these 2 points, if I am having 10 meter distance, okay, no, then corresponding to this 10 meter, where it can lie, that I have to find out. So how the way I am going to find out the difference and average of reading, that will give the estimation point. Okay, so for preparing this, I have to make all the lines in the scale diagram. Okay, now so 101.1 minus 100.8 divided by 10, so that I can get the value of 0.03 meters. So from here, if I am going to take 0.03 meters, okay, now I can get the value of 101 meter contour. Okay, so likewise here it is 101.1, here it is 100.9. so the difference divided by their corresponding horizontal equivalent distance. Okay, now so that I can able to get my position of the contour line of 101 meter. So likewise, if I am doing the calculation, then it should be called as by estimation method. Okay, then another method is in arithmetic calculation method. Okay, now so likewise we are going to get our contour position, okay, with respect to the indirect method of our calculation. Okay, thank you.